So now we are going to look at another common example of permutation problems, where you're given words and have to figure out how many possible ways there are to rearrange it. So for example, how many permutations are there of the letters in the word saw? Well, we could look at it in two different ways. We could actually make a complete list. There are two different ways we could start with the letter S, two different ways we could start with the letter A, and two different ways we could start with the letter W. So we can make a list and get 6 of them. We could also use our fundamental counting principle, saying we have 3 choices for the first letter, 2 for the second, 1 for the third, also get 6. Or finally, 3 permute 3 with our formula is going to be that n factorial over n minus r factorial. Here that's 3 factorial over 3 minus 3, or 0 factorial. So right here, this is the piece that we needed. This is why we introduced 0 factorial, to show that it equals 1. Because it does turn up when you're doing permutations of objects and use every object in the set. But this is 6 over 1, or 6. So it's not too hard to do that when we've just got these 3 letters. What if the word is paintbrush? Well, we can count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So if we're doing 10 permute 10, this is going to be 10 factorial over 0 factorial, or 10 factorial possibilities. Now, 10 factorial possibilities works out to 3,628,800 options. Doing it with permutations, that formula works out nicely. Fundamental counting principle wouldn't be too bad. That would also get us to the 10 factorial. We do not want to do this one by listing word after word after word after word and trying to make sure that not only is our list complete and devoid of duplicates, but that we actually have counted it manually correctly. Because 3 million of these. It's definitely much faster to do it by hand. But now, what about the word mom? You would think, oh, it's 3 letters. It's going to be the same 6 options that we had for was and saw. Well, let's take a look at those. We've got the MOM we start with. We can make another word by swapping out our first and last letters, which is still mom. We can put the O up front, and then we have 2 M's here. See, if we try to do it manually, we don't actually get 6 different options. Now, if we could tell the M's apart, well, that would be different. Right? If we, say, had a black M and a blue M, well, then we would have 6 different options, but we don't. We've only got 3 differences. There's O in the middle, O at the front, and O at the end. So how do we account for this? Well, what's really happening here is that once we've written down, or once we've written things out, we can start rearranging them. So we know that we've got 3 factorial ways to arrange the letters, but then we're counting twice, because for one arrangement that we can see, we have 2 duplicated M's. So we have 2 factorial ways to rearrange those M's and get exactly the same pattern. So we have to divide by 2 factorial, because every answer can be swapped out that way. So this just gives us 3. So in other words, if we're doing this in general, let's say the word is paintball. Well, if we want to arrange this one, we're going to have to go through a lot of different options. This is a 9-letter word with 2 A's and 2 L's. So we're going to break this one down into its own video.